Hello everyone, welcome to Canal Physics. Today we are looking at rules for writing numerical answers. When writing a numerical answer in physics, it's important to think about how many digits we write down. And the number of digits we write down depends on the operation we perform or operations we perform. So the first dot point reads, when adding and subtracting, the result must be quoted to the lowest number of decimal places, and when multiplying or dividing, the result must be quoted to the lowest number of significant figures. Let's consider the rectangle below. It has a long side of 5 centimeters and a short side of 2.25 centimeters. And part A is asking to calculate the perimeter. That is quite simple, but we're thinking about how many digits are we going to write down when we get the perimeter. As with any polygon, we simply add all the side lengths to get the perimeter. So for this rectangle, that's 2 lots of 5.0 plus 2 lots of 2.25. And putting this in our calculator gives us 14.5 centimeters. So before we leave this as our final answer, we must make sure this is to the appropriate number of decimal places. And that's because we did addition to get the perimeter. So we must look at the original data provided. So we can see 5.0, 2.25. Out of those two, 5.0 has the lowest number of decimal places, which is 1 decimal place. So by the first bullet point rule, we must ensure that our final answer is also to 1 decimal place. So we can leave that as our answer. Now let's calculate the area. To get the area, we multiply the dimensions. And this is what we do for all rectangles. And putting this in our calculator gives us 11.25 square centimeters. To figure out how many digits I write this answer to, I again consider what I did with the original numbers, and that was multiply. And when I multiply or divide, I have to make sure the answer is to the lowest number of significant figures. And so if I look at my original two numbers that I used, 5.0 has the lowest number of significant figures, has 2. 2.25 has 3 significant figures. So I can see that what my calculator directly gave me, 11.25, that is too many significant figures because I have to make sure it's only to 2 significant figures, the lowest number of significant figures from the data. So I can use rounding to adhere to this rule and write that as 11 square centimeters. And that's it. Let's try a more complex example. Here we have 10.35 squared minus 20.0 divided by 6.0 plus 1.00. We'll just deal with one thing at a time and it will make it a lot easier. So we're trying to get the answer but express it to the appropriate number of digits. So 10.35 squared, if we put that in our calculators, we will get 1.07.1225 as the full number. Subtract 20.0, and we can deal with the denominator as well, because we're just following BIMDAS here as we go. 6.0 plus 1.00, that's going to be 7.0, because I have to go by the lowest number of decimal places for out of 6 and 1. And that's 1 decimal place, so 7.0 is 1 decimal place as well. But this 107.1225 must be written to a lower number of significant figures because that came from 10.35 squared. 10.35 squared, that is just 10.35 multiplied by itself. So that is a multiplication in effect. So we must go by the lowest number of significant figures. But since it's just one number, we go by those significant figures, which is 4 for 10.35. So 107.1 is also to 4 significant figures, which is good. Okay, what's next is the subtraction on top. Again, just following BIMDAS, that's going to just be 87.1 over 7.0. Now at this point, I think it's important to point out that I am writing down the numbers as I go to the appropriate number of sig figs or decimal places, but in my calculator, to get the next numbers, the next lines, I am writing the full number in my calculator. So to get the 87.1, I didn't write 107.1 take 20.0 in my calculator. I wrote 107.1225 minus 20.0 in my calculator because I want to save all my rounding till the very end, till I get my final answer, so I don't get off by a couple of digits, either to the first decimal place or second, for example. So in short, we must make sure in our working, when we're actually doing it in the calculator, that we're carrying all digits through and saving all rounding to the end. Okay, so that being said, the next line is going to be just 87.1, etc., based off the full numbers from above, over 7.0. And this is a division, so I go by the lowest number of significant figures, which is 2 significant figures from the 7.0. And that gives me an irrational number, 12.446, etc. And I must round this so that there's only 2 significant figures, which is just the whole number 12. And that's it. Let's calculate the perimeter and area of the circle below to the appropriate number of digits. And in doing so, we'll learn a new rule for significant figures. So the perimeter of a circle, also known as the circumference, is given by 2 pi r, where r is the radius. We can see that r is 0.26 meters, so let's just go ahead and substitute that. And our calculators give us an irrational number, which is what we expect with formulas involving pi, which is also an irrational number. We get 1.6336, etc., meters. And how do we know how many digits to write? Well, since r is the only variable in this formula or the only bit of data that we need, it's going to determine the number of significant figures we write in C. 2 and pi are constants. Constants don't affect the number of significant figures. And yes, we do go by number of significant figures for these cases where there's only one possible variable. And therefore, since r has 2 significant figures, 0.26, we will write 1.6 for our final answer for circumference. And that's that. Now for the area. The area of a circle is pi r squared. And plugging this in and typing it into our calculators, we get 0.2123, etc., square meters. Now, in a very similar way, we can see that r is the only variable that could possibly affect the number of digits. And yes, it is going to be it's going to determine the number of significant figures we write in A. So since r has 2 significant figures, yes, it's squared, but that's still going to be 2 significant figures. 0.26 times 0.26, that's a multiplication. So that's going to mean r squared has to have 2 significant figures, which means A has to have 2 significant figures. So we're going to round and write 0.21 square meters. And that's it. It is common to use right-angle triangles to solve physics problems. So there is a simple rule to decide how many significant figures to write for trig ratios. And this is that we simply write the same number of significant figures in the ratio as the angle. And this goes for sine, cosine, and tangent. So we see these examples here. Sine of 60.0, 3 significant figures in 60.0. So we write 3 significant figures in the ratio, 0.866. 2 sig figs for 25, and this is cosine, but it's the same rule. 2 significant figures, 0.91. 1 significant figure in 30, so the tangent of that is also going to have 1 significant figure, 0.6. And these are all irrational numbers, but we use rounding to adhere to this rule. Thank you for watching this video. If you found it helpful, please like and share it, and subscribe to my channel for more.